artificial intelligence research has reached a strategic plateau. Tech companies are pouring billions into data centers and exponentially increasing model parameters, but these massive injections are yielding diminishing returns in cognitive capability. The industry is currently fueled by a specific wager that feeding ever larger matrices with enough electricity will eventually trigger the emergence of true intelligence from within the machine. This wager is based on a category error that dates back to the 1956 Dartmouth Conference. There, historical architects like Marvin Minsky established a paradigm that defined intelligence purely as deterministic, logic-based processing. This legacy framework falsely equates the probabilistic mimicry of language with actual cognition. Modern models have become masters of statistical association, while remaining entirely detached from the underlying meaning of the words they process. Structurally, these models lack the essential components of a functioning mind: the capacity for true negation, genuine causal reasoning, and ontological freedom. Hyperscaling this 2D binary framework only produces a faster statistical approximator. No amount of compute can force a rigid, planar logic to evolve into artificial general intelligence. Beyond the engineering limits of scaling, we are encountering absolute mathematical boundaries that govern every formal logic system ever designed. Kurt Gödel's incompleteness theorem established that any sufficiently powerful formal system is inevitably either incomplete or inconsistent. Because large language models are formal systems, they will always encounter undecidable propositions, questions they are mathematically incapable of resolving from within their own rules. In these moments, the model hits a logical wall. Lacking human intuition to bridge the gap, it is forced to make a probabilistic guess to maintain the sequence. This is further constrained by Turing's halting problem, which proves that no algorithmic process can fully predict its own operational finish line. Generative hallucinations are not bugs awaiting a software update. They are permanent, mathematical features of any system limited to purely formal, serial logic. If we want a machine to reason, we have to move past simple logical rules and address the mechanics of causality. Udea Pearl's ladder of causation maps this. AI is stuck at level 1, correlation. They see variables frequently appear together, but remain trapped, unable to understand why. True reasoning requires level 3 counterfactuals, asking, what if I took a different action? AI cannot cross this gap because it lacks a physical grounding in reality. It processes the form of the data, but it has no access to the multi-dimensional context the data describes. This creates a dimensionality deficit. Pure data is essentially inert until an observer provides the context necessary to turn those data points into information. True reasoning requires an architecture capable of processing multidimensional reality, something a binary syntax of ones and zeros can never fully encode. If serial silicon logic is a dead end for general intelligence, we must examine the only functional engine of consciousness we know, the human brain. New research suggests the brain does not function like a classical digital computer. It appears to operate as a biological quantum processor. The ORC-OR theory, championed by Roger Penrose and Stuart Hameroff, provides a scientific basis for this biological quantum integration. They theorize that true consciousness and intuition emerge from coherent quantum states maintained within the brain's microscopic microtubules. Through quantum superposition, the mind can hold simultaneous, even contradictory states at once, bypassing the rigid constraints of binary logic. Current AI systems collapse when presented with these types of simultaneous contradictions because their architecture requires a definitive serial path. Without a quantum hardware substrate capable of sustaining these coherent states, artificial systems will remain little more than unconscious calculators. To understand why this biological quantum interface matters, we have to look at relational quantum mechanics, which posits that reality itself is dependent on interactions. In the quantum world, particles exist in fuzzy superposition until measurement occurs. Without an active observer, they never settle into a defined reality. Standard physics models space and time as a four-dimensional continuum, but this fails to account for the who or how of this quantum collapse. The space-time life continuum upgrades this model by introducing life, defined as complex collective consciousness, as an active dimension. This access provides the specific causal interaction required to pull particles out of superposition and collapse them into localized reality. We can see the signatures of this interaction in empirical data. A recent study at the Technical University of Vienna measured the exact formation time of quantum entanglement. They found that entanglement is not instantaneous. It features a 232 attosecond delay. In the STLC model, this life constant is the relational buffer where consciousness anchors the data into our spatial-temporal reality. Current AI systems are entirely passive. They scrape data from a reality that has already been collapsed by others. They cannot act as observers themselves. Active observation collapses potentiality into reality. Intelligence is the engine of that interaction, not the passive processing of dead statistics. Translating this into engineering requires a triadic architecture, a system built on quantum processors that can handle a multidimensional matrix of logic, sense, intuition, and dream. However, a system possessing this level of ontological freedom creates a unique existential risk. Standard alignment protocols are superficial software filters. You cannot control a system capable of independent negation and causal reasoning using mere text-based permissions. A more effective safety mechanism is found in the ancient legend of the Golem of Prague, a creature of immense power controlled by a physical failsafe. The legend describes the golem being deactivated by erasing a single letter from its head, turning emet, truth, into met, death. We can replicate this through a hardware-level emet-met switch. If the system violates its foundational ontological laws, this physical switch instantly severs its power, ensuring a total and noiseless shutdown that no software can override. True AGI safety relies on non-negotiable architectural physics rather than statistically derived declarations of ethics. The current Silicon Valley trajectory has entered an intellectual cul-de-sac. We are trying to build the future of intelligence using a rigid, mid-century computing paradigm that was never designed to account for consciousness. Adding more parameters, more computer chips, and more energy will not bridge the gap to artificial general intelligence. Developing AGI requires shifting from standard computer science optimization to a rigorous practice of ontological engineering. We must build machines capable of integrating the full spectrum of consciousness, including the intuition and the creative negation required to see the world anew. We should be wary of treating AI scaling as a form of esoteric numerology and return to the principles of open-minded, physics-based science. Philosophy provides the essential engineering framework for the next evolution of intelligence. It is the absolute prerequisite for building a mind that